Hello everyone, welcome to section Java Object-Oriented Approach, and topic is declare and instantiate Java objects, including nested class objects, and explain the object's lifecycles, including creation, dereferencing, by reassignment, and garbage collection. Please watch my video till the end. If you like my video, give thumbs up and click the bell icon to subscribe to my channel for the latest updates. Class is a template of an object. It contains field, which we also called as variables, initializers, constructors, and methods. So field define the state of the class and method define behavior of the class. Object or instance is a runtime instance of a class in the memory. To create an object, we need to declare, instantiate, and initialize. To declare an object, we need to use variable name with variable type, and it stores in the stack of memory. With a reference of an address, when we write the new keyword to instantiate, it creates the space in the memory to create an object. The constructor creates actual object, and the reference of object in the stack points the object in the heap. There is one more block, is called as a static block, and here you define all constant and statics. I have created a project in IntelliJ named Java Objects, and it has one class main. Type with a reference variable is declaration. When we assign new with the constructor to the reference variable, it creates the space in the memory and the object, and this is called as initialization. The using of new keyword creates a space in the memory. Creation of a space is called as instantiation. So we have written the creation of object in 2 steps. We can do in 1 step as well. So this is in a 1 line. And now we can use any method defined in the random class, and this next int will returns the number from 0 to the number mentioned as a parameter in this method. So it's going to be 0 to 10. Let's run this class, and it has given 5. Okay. Next topic is nesting. In nesting, there is a top level type, which we also called as enclosing type or outer type, and nested type, which we also call as enclosed type or inner type. This top level type could be class, interface, or enum. This is top level type, and this one is nested type. So top level type is not defined within another type. It can only be set with public or default access, which we also called as package private access modifier. A Java file can have many top level classes, but at most one public top level class. In fact, it may have no public class at all. So the public class must match the name of the file. Next, enclosed level type, inner level type, or nested type. For OCP exam, we mainly see questions regarding nested class, so we will not discuss interfaces and enum. So nested class is a class that is defined within another type. There are two types of nested classes. One is static, another one is non-static, which further divided into three classes: inner class, local class, and anonymous class. Static nested class is a class which defined as a static type at the member level of the class. And in non-static nested class, inner class is also a class which defined at the member level of class. Local class defined within a method body, and anonymous class is a special case of a local class that does not have a name. One thing you need to note that interfaces and enum can be declared as both inner classes and static nested classes, but not as local or anonymous classes. And we will see all of them one by one. So creating a static nested class. A static nested class is a static type defined at member level. Unlike an inner class, a static nested class can be instantiated without an instance of the enclosing class. The trade-off, though, is it cannot access instant variable or methods in the outer class directly. It can be done, but require an explicit reference to an outer class variable. Let's create a Java class enclosing. And create static class nested with a private instance variable price and private static double instance variable rate if we would like to access the static variable, we can do like enclosing dot nested dot rate. We can also write nested dot rate, which means that the nesting creates a namespace between the enclosing class name must be used to refer it. So we have used the enclosing class before the nested class. Okay. Next, it can be made private or use one of the other access modifier to encapsulate it. So you can use here private or public or protected, and if you do not use any modifier, it's a default modifier. Enclosing class can refer to the fields and the method of the static nested class. So you can see that this is outside the static class, and I can access this instance variable. However, we can also access the private member, but you need to create a reference of it. Okay. So this one is 8, this one is 8, and this one is 6. Now I'll show you importing a static nested class. Let's create a class in a bird package 2con. And this class has a static class beak. Now create another class in a separate package, watcher, and the name of class is bird watcher. If I would like to use beak in 2con class, so I can import that class in two ways. And which is regular import. You can also use static import. Because beak is a static class. So make sure if it comes in the exam, do not get confused. Right? Next is non-static nested class, and the first one is inner class. So an inner class can also called a member inner class, is a non-static type defined at the member level of class. Let's see an example. Let's create a class named outer, and this class has a main method and create an object of outer class. This class has inner class. This inner class has instance variable, repeat, and instance method go. This go method has a for loop and this for loop trying to print an instance variable of the outer class named greeting. So inner class can access the outer class members. Members means fields and methods. Let's create one more method called inner, and in this inner class and in this method create an object of inner class and call go method. Here you call that inner method here you call the outer class call inner method, which in turns call go, and it prints 3 times high. All right. There is another way to call this go method, and that is creating an inner class object by the reference of outer class. And then inner dot go. So it does the same thing. Okay. Now 6 times. can see that you can create the inner class object by the reference of outer class. So inner class can be declared public, protected, default, or private, right? So we have seen that here inner class we have declared protected. So I can use all 4 modifiers. So the inner class can extend any class and implement interfaces. So this class can extend any class, like extend main class, which is this one, or if it's any kind of interface, it can also implement the interface. Can be marked abstract or final. So this class can be marked abstract, and then you can define any abstract method, or you can also define final to stop inheritance. Cannot declare static field or methods except for static final fields. So we can write any constant inside the static class but we cannot define any static method or static field. Can access members of the outer class including private members. So you can see that this is a private member of the outer class and inner class can access this one. Let's see one more example. Make a class A, and in this one we see that the inner class can have the same variable name as outer class. So let's make class B, and this class B has inner class C. Okay, and the A class has instance variable X, B also have the X variable, and C also has X instance variable. All right, let's give the A class instance variable value 10, B class instance variable 20, and C class variable value 30. Now in C, create a method which print all of the X. If you write X here, it will print the X of class C, which is 30. And if you write this dot x, so it will give the this class, the C class instance variable value 30. For calling one step outer class B instance variable, you need to mention here B, which gives 20, and then for A class you need to write A dot this dot x, which gives 10. If you would like to run this program, need a main method, create class A variable, and you know that if you want to create a inner class, so you can create by the reference of outer class. And same thing, if you would like to make an instance of class C, you can make through the reference of outer class B. Remember that you can also write this one as A dot B, and similarly this one as A dot B dot C. And from C, all of the x, if you call it, it will give the desired output 30, 30, 20, and 10. Okay. Let's see one more example. And let's create a class fox, and in this program we will learn about the inner class require an instance. So let's make a private inner class then, right, and a public method in outer class go home, and the static method in outer class visit friend, and then make another class squirrel, and it has a public method visit fox. Okay, so this is a private class, uh, two methods, instance method, static method, and this is second class, and then it has instance method. So you can see that there are two classes in one file, and I put the public with the fox, not with the squirrel, because whenever you put the public, the class name matches with the file name. Okay, now if I would create an object of private class, it is allowed over here. So this private class treat as a member, and it is non-static class. So non-static member we cannot access through the static area. But if you would like to use a private member, as you have learned, you could do it through a reference of outer class or an object of an outer class. Through a reference of an outer class which contains the through a reference of an outer class which points to the object of outer class. So the same thing, then is a private. Can we do it in a different class? No, it's completely unknown, because this then is private to this class. What about the way I have done here with a object of outer class? No, it also gives a compiler error. Okay, so make sure that you understand this. Okay, we can access the members of the outer class including private members. Next, local class. A local class is a nested class defined within a method. Like a local variable, a local class declaration does not exist until the method is invoked, and it goes out of the scope when the method returns. This means you can create instance only from within the method. Those instances can still be returned from the method body. Local classes can be declared inside method as well as constructor and initializer. So let's create a local class, come back and go over one by one. I make a class name print numbers, and let's make a main method and object of a class and call it outer. All right. Private instance variable length, public instance method, public instance method calculate, and in this method we are going to create a local class. And this local class has a method multiply. All right, so this one has length. Here make a final int width, and here try to multiply by length into width. Okay, so the scope of my local class is within the method body. I'm going to create an object of local class and call multiply method of a local class. So how can I assess this calculate? Very simple. Outer dot calculate, and let's run this program, and it gives 100. 20 multiplied by 5, which gives 100, right? We call the calculate method. What it does, it creates the variable nested classes, and then it creates an object of a nested local class and call the method. It prints 100. Okay, now create another instance method, process data, and in this one define a local variable length, local variable width, and height, and then make a local class volume calculator. In this one, create a method multiply, which returns length, width, and height, product. So if I define here final, so this local variable cannot be changed throughout the scope of this variable which is inside the method. And what about the width and height? They are effectively final. It means that if you do not mention the final and do not reassign these do not reassign the value to these two variables, it will compile. But the moment we assign a value, it gives a compiler error. Okay, so let's comment this one. This is a explanation of effectively final. So local class, they do not have an access modifier. You can see that here you cannot put public, protected, or private. So the local class is available throughout the scope of method, and they cannot be declared static or cannot declare static field or methods except for static final fields. So they cannot declare as static or static final field, but it can declare the constant field, which is static final. Okay. Even to change the method to static, you, you cannot put the static over here. Okay. Next, they have access to all field and method of enclosing class when defined in instance method. So if it is a instance method, it can have an access to all the fields which you have used inside the class. They can access local variable if the variable are final or effectively final. So you can see that these two are effectively final, and the moment you try to change the value of width, it gave a compiler error because it won't be effectively final if later on we change the value of variable. Next is anonymous class. So anonymous class is a special form of a local class that does not have a name. It is declared and instantiated all in one statement using new keyword, a type name with parentheses, and a set of braces. Anonymous classes are required to extend an existing class or implement an existing interface. Let's create a class named Zoo Gift Shop 1. Create an abstract class sale today only, and it has abstract method, return type integer, dollars off. Now create an instance method with a parameter of integer type base price and create an anonymous class with a new keyword, the constructor of abstract class with two braces and implement the method. In this one, return 3. Okay. So this is an extension of abstract class. So we can also say that it will create an anonymous class whose super type is this abstract class, and we can assign anonymous class into the reference variable of abstract class. Remember that you have to put the semicolon here. So this is a one statement. And here return base price minus sale dot dollar. Okay. So this is the extension of abstract class. So you can say that this abstract is a child class of object class, and this anonymous class is a child of abstract class. These are the three classes in hierarchy. Now I'm going to do the same thing with interface. Interface sale today only, and here you declare an abstract method dollars off. Remember that this abstract method is by default public and as well as abstract. If you do not mention the access modifier, it doesn't mean default, it means public. And public int admission int base price and here I am going to create an anonymous class same like as before and assign this to a reference of interface, and then return base price minus sale dot dollar off. Okay, so this anonymous class is an extension to interface. Remember that this is an interface, not a class. So the superclass of this anonymous class is object class. Okay. Okay, so in anonymous class, you have seen that they do not have access modifier and name. They cannot be declared static, final, and abstract. Okay, so you cannot define modifier, you cannot put static, final, and abstract keywords. However, you can extend them from abstract class. If the extension is from an abstract class, then it is extended from that abstract class. And if it is made by an implement, then that is an extension of object class. They cannot have constructor. So if you like to put here some kind of a constructor, so it will give you an error, no constructor. They can be defined where they need it. I will create a class name zoo gift shop 3, and it has an instance method public int pay and another method public int admission. Okay, let's create an interface same as before. And here in admission put int base price and the other one sale of today and here you return base price minus sale dot dollar off. Here you are going to call admission base price 5 and new sale of gift shop, and here you return 3, right? So now you can see that we have defined this anonymous class as an argument. So you can define anonymous class wherever you need it. Okay, let's see one more example. Let's make a class gorilla. It has interface climb and you can define anonymous class at field level. Okay, so you can define wherever you need it inside the method as an argument nearby the field. They have access to all fields and method of enclosing class. So you have seen that one. They have access local variables if the variables are final or effectively final. So same as before, that if you define a variable over here, so do not change the value of that variable. That variable would be an effectively final, and you can use over here inside. Okay, like int local equals to 0, and here you can do 3 plus local, and you can see that this variable is effectively final, because the moment if you change this one, compiler will give you an error. One thing I would like to mention over here, that as I have stated, the anonymous class you can make either from abstract class or interface. So if you make from the anonymous class from abstract class, that is child anonymous class of an abstract class, and that abstract class follows the hierarchy down below object class. The same thing over here, if you create an anonymous class with the help of interface, so the direct parent class is object class, and here you can override all the object class methods. So you can see that the anonymous class, this anonymous class without name, is actually extending from object class. All right. Modifier to nested classes. There are two types: static and non-static. All modifiers, public, protected, private, and default, are allowed with static nested class. For non-static, only inner class can have all access modifier, not in local and anonymous class. We can write abstract and final with the static nested class and inner and local non-static nested class, not in anonymous class. So anonymous class cannot be abstract and final. Permitted members. Members can be methods, variables, blocks, and nested types. Here we'll see only methods and variable. Two types, instance and static. In instance method and instance variables, those are allowed in static and non-static nested classes. Static methods are allowed in static and non-static nested classes. Same thing with static variable, but non-static nested classes allowed static variable if they are final, which means that they must be constant. They won't change throughout the program. Okay. The exam might try to trick you by having a static class access an outer class instance variable without a reference to outer class. For that, this table is beneficial. There are two types of nested classes: static and non-static. Can static class extend any class or implement any number of interfaces? Yes. Same thing for non-static, but for anonymous class must have exactly one superclass or one interface. So what it means that one superclass is what? It's an abstract class. If we are creating anonymous class through abstract class, and for interface, the superclass would be object class. Object class. So remember that anonymous class built either by abstract class or by interface. So if we create through abstract class, the superclass would be that abstract class. And if we create through interface, the superclass would be object class. Can static nested class access instance member of enclosing class without being referenced? No, we have seen this one. We have to create an object and the reference to access the instance members. Inner class, yes. Local class and anonymous class, yes, if declared in an instance method. Okay. This question is for local and anonymous class. Can access local variable of enclosing method? Local class, yes, local class can access the local variable of enclosing method, but they must be final or effectively final. Effectively final means the value is not changing once it declared. Okay, same thing for here, anonymous class. Next topic is memory allocation. So as I have described earlier, in Java we have stack, we have heap, and we have special section for static data, and also there is a certain portion for bytecode. So what is a stack? Stack, it is a space where the local variable gets space. The variables which are declared within a function live in stack. So here we define methods, local variables, and reference variable. Okay. Heap is the dynamic memory that can grow or shrink as per our need. It also called as free storage. The size of all other segments is decided at compile time, but the heap can grow during runtime. We can control memory allocation and deallocation in heap space. Heap, we have objects and the reference points from stack to heap where the object is located. In stack, whenever the reference variable creates, it has some address. For instance, this is an address and this is an address, and if the address matches to the address of an object in the heap, it creates a link between the reference variable and object. Okay. Static or global. It is a space to store all global variables, variables that are declared outside functions and are accessible to all functions. So those declare over here, like your constant, the static members which are accessible throughout the program. Code, to store all instructions in the program, the instructions are compiled instructions in the machine language. So those are stored over here in the code section of memory. Whenever you create an object, a reference store in the stack, an object stored in the heap. A reference may or may not be created on the heap. All references are the same size, no matter what data type is, and are accessed by the variable name. Okay, so this is the variable name and this is the address. And objects are always on the heap. They have no name and can only be accessed via a reference. Objects vary in size depending on their class definition, okay, which is very clear. Okay. Next, let's see the difference between stack and heap. In stack, we store methods, local variables, references to objects. In heap, we have actual objects. In stack, the elements store in LIFO order, like last in, first out. So this one will go first, then this one, then this one. Okay. And in a heap, the order of storing object is as per memory management techniques. The life of elements in the stack is depend upon the method frame and the objects based on the application. The size of stack is smaller, and heap has no size limit. It is dynamic, it can grow and shrink. If we access any reference to the object or method local variable in the stack, it's faster to access, and if we want to access any object in the heap, it's slower. The stack memory allocated during the method call and deallocated when method return. The heap allocated when we create an object and deallocated by a garbage collector. When the memory is full in the stack, it will give a stack overflow error exception, and when heap is full, it gives out of memory error exception. Garbage collection. Garbage collection is the process of automatically freeing memory on the heap by deleting objects that are no longer reachable in your program. So the concept of garbage collector is that it automatically looks for objects that are not needed anymore and collect them as per its own time. The concept is pretty much same like in the United States. We have certain garbage days and we put the garbage outside on that particular day. There is no set time of a garbage truck to come and pick up the garbage, but they do within a time frame which they have allotted. It is the same when object is eligible for garbage collection. Garbage collector comes its own time and release the memory. And this whole process is going on inside JVM, and it is JVM responsibility to perform garbage collection. There are certain conditions for the eligibility of garbage collection. When an object is no longer reachable, when one of two situations occur, the object no longer has any reference pointing to it. All references to the object have gone out of scope. It is the JVM responsibility to actually perform the garbage collection. Remember that reference is a variable that has a name. Garbage collector collects the object in the heap, not the reference in the stack. I would like to explain this process through a couple of examples. This is example number 1. We have a class main, and this class have 3 methods, M1, M2, and M3. From main method, we are calling M1. M1 is calling M2, and M2 is calling M3. In M3, we are creating an object of account class. We have a main class and we have an account class. So when the program runs, it allocated the space for main method and its parameters plus variables. This space is a small space with an address of an object. Here we are creating the main class object. The reference, which is the name of the object, is here with the address, and object will create in heap. When the object create, it would have an address, then object call method M1. The method frame of M1 and the variable inside the method stores in the stack. M1 call M2, it has one parameter and one local variable, both stores in stack. And then M2 call M3, which has a reference to a account object which stores in stack, and object is going to create in the heap of account class. Account class has two instance variable, and the link has created between the stack and the heap through these addresses. Okay, it could be anything. I just put it over here, 100 and 201 for the learning purpose. In heap, we also have string pool. Beside heap, we have static area and instruction area. Once the control returned from M3 back to M2, this account object is eligible for garbage collection. So garbage collector will come its own time and pick it up. Our program find out there is no need of B and C, so stack could take them out, and also can take out M3. Then the garbage collector comes and pick it up. Then control has gone from M2 to M1. The same thing happened here. And in M1, the control goes back to the main method. And when the control goes out of the main method, the object in the heap eligible for garbage collection. Main method frame may go out of stack memory, and garbage collector comes its own time and collect the object. In string pool, we store the strings, so it is for fast processing. If we have the 4 string objects and the value of a string is same, instead of creating string repeatedly, memory store the string in the string pool and access the same string in a faster fashion. This one I have described in the previous slide of strings. This is example number 2. Here we have a main class which creates an object of class A, and class A creates an object of class B. This is stack, this is heap. In stack, this is the main method frame, and it contains the reference of class A object. It points to the object in the memory, and reference can store in the heap as well. That's why I'm showing this one. It's not like we always store references in the stack. We can store references in the heap, but we cannot store object in the stack. Okay. Child is a reference of object B, and in object B we have 2 instance variables. Now you can see that how a reference in the stack pointing towards an object in a heap, and the object in the heap is referencing another object in the heap. So Java includes built-in methods to support garbage collection that can be called at any time. The first one is GC, which is in the system class, and system class is in java.lang. It just suggests that JVM run the garbage collector. The JVM may perform garbage collection at that moment, or it might be busy and choose not to. The JVM is free to ignore the request. So JVM has free will. It is not guaranteed to run or do anything. The next method is finalize. It is in object class. Java allows objects to implement a method called finalize. This feature can be confusing and hard to use properly. In a nutshell, the garbage collector would call the finalize method once. If the garbage collector didn't run, there was no call to finalize. If the garbage collector failed to collect the object and tried again later, there was no second call to finalize. This topic is no more in the exam, and the finalize has been deprecated. Just remember that this method can run 0 or 1 time. It cannot run twice. This is example number 3. I will do this example in IntelliJ. Let's create a class scope and define a man method. declare toString 1 and 2, then initialize the first string and initialize the second string. Now you write 1 equals to 2. It means that assigning 2 into 1. At this point, this object, you can say string A is eligible for garbage collection. Okay. Now declare another string reference 3 and put 1 in it. So the reference of 1 is in 3 now. Now right here 1 equals to null. So this is, you are breaking the link of reference number 1 to string B. And here, when the program go out of the scope of main method, string B is eligible for garbage collection. Alright. To explain all of that with a diagram, this is a stack and this is a heap. So the string reference 1 pointing towards a string object A in the heap, and string reference variable 2 pointing object string B in the heap. Where you assign reference of 2 to 1, it means that you are breaking the link of 1 to A and creating a link of 1 to B. And now this one, A, is eligible for garbage collection. And then you assign reference 1 to 3. It means that 3 is also pointing towards the same object of 1, which is B. 1 equals to null. It means that you are breaking this link. And at this point, only 2 and 3 are pointing towards object B. So here, object A is eligible for garbage collection, and here reference 1 is also eligible for expunging out from stack memory. And when program controls out of the scope of main method, then the link between reference 2 and 3 break with object B, and all of them would be eligible for garbage collection. Let me explain you a finalize method. When we run the program, the finalize may run or may not run. So the program finishes before the running finalize, and make sure that this code runs only once or may not run. Okay. So I hope you like this video. Wish you best of the luck for your exam. Thank you.